Okay, let me be a baby.
Well, if you are finishing up, I'm gonna. Oh, I knew there was
I'm
another.
gonna be a baby now. Like, I'd rather be young right now than be old and holding me back. Like, I'm not. I ain't worried about that. Holding you back. I mean, I think anybody's game. Yeah, for real. He would be a super senior.
So they're like already in it.
Did you feel like that? Yeah. I'm surprised I was doing that. Right, surgery was very common. Bypass that. Well, first was I had to do the last period. I'm not going to do this period. Can you please stop?
All right, here we are, page 301. I'm gonna go ahead and get started. We can just have a class discussion about it. Pretty much I'll talk and we'll see. All right, I think this is interesting, probably because I have actually lived life with a landline phone. Um, like this phone over here is connected to the wall. How many of you guys have phones connected to walls in your houses? Right. Some people living with their grandparents might because they feel like safer with one. And honestly, I think we probably should have a landline in our homes. But I think this is interesting, and I try to think because I remember a time where there weren't cell phones and we all had landlines, and it was really cool when we had a cordless phone and we could walk out front and talk or out back and talk on the phone, but we couldn't really go past our yard. It wouldn't work. There's probably too many. You're just gonna have to jiggle it. Anyway, I think about, when you're older, what type of technology. So what kind of stuff do you guys think? Shh. What kind of stuff do you guys think we have today that won't be around when you're older? Actual paper books.
Oh, paper book.
I don't know what kind of future you're looking at.
Any other ideas? I got a real one. That I think is true. I think by the time you guys are like grandparents, we won't have TVs anymore. I think everything will be a projected hologram. And you guys will remember a time where we had physical TVs plugged in. And in the future, it'll be like we could project I'll be able to project on that wall.
So like a
I'll
projector.
project it here. Well, right? Those are still. You can do that right now. You can project from a cell phone right now if you have a certain cell phone. But I'm talking like a 3D, to where like you're watching a movie right here and it's kind of like a hologram. I think that's going to happen in your lifetime. And you're going to think back and you're going to look at a graph like this and you're going to be like, yep, I remember when there were regular TVs. I remember that. And then the people your age are going to be like, what are you talking about? A TV? Because everything's going to be 3D to them. Anyway, let's read this graph. Physical money. That terrifies me. I don't know if that's just because of my age, but I get real scared when I think about no actual money. Now it's just numbers from bank account to bank account. They give me numbers for being here. I give my numbers to Publix. I give my numbers to the electric company. And then I actually don't ever see the money. I'm just switching numbers between bank accounts. It's kind of wild, you know? You're right, money. All right. So, guys, who can make an observation about this graph? Can you make an observation about the graph? Anybody? Yes, Landon. It's showing the percent of people who use landlines. What year does the graph begin? So that was before y'all were born. Actually, I'm going to go ahead and say it's 05. So this is claiming in 2005 about 8% of people had cell phones. That's not a lot, guys. I was in high school in the 90s. And I got a cell phone my sophomore year, but I had to buy a card from the 7-Eleven and load money on it. And then it lasted like all month. But I knew every time you made a phone call, you saw your money go down. Anyway, in 2018, or what happened between 2016 and 2017? What happened? The number of people with cell phones got higher than the number of people with landlines. So it wasn't until really like 5-6 years ago, data shows that there's more cell phones around than there are landlines. We still got landlines here in the school. That's kind of weird, isn't it? I can't imagine a school that doesn't have landlines. Yeah, you're not supposed to. You're right. But we all have cell phones, and then every time I lost my cell phone, the office couldn't get a hold of me. That would be bad. Okay. Your friend thinks something is wrong with the graph because for a given year, the 2% do not add to 100%. Is your friend valid? Okay, so the point here is that it's 10% and 86%. So that means it's only about 97%. Where's the other 3%? You think no phone at all? Yeah, no phone at all. Okay. You want to write an equation that represents each line. What do you need to consider? What do we need to write the equation? It's talking about this. What would you need to do this? Anybody? What would you need? What do you need to write an equation? What? Yeah, what do we need to know to write an equation for a line? Yeah, what do we need to know? What? We got our y is percent, our x is years. How do I write an equation for the blue line? What do I need? We need slope. We'll have to count slope. So I got my y-intercept at about 8. I need slope. And what do we think slope is? It's going up 10 over 1, 2, 3. So my slope is up 10 over 3. That means every 3 years, the percentage went up about 10%, the amount of households that have cell phones. Good question. That's the y-intercept between 0 and 10. You see my little red circle? I think that's 8. So anyway, approximate the slope of the line up 10 over 3. I get it. Let's move on. So today's goal is to write equations in slope-intercept form. There's 3 skills that go with this chapter, 4.1. The first skill is to write the equation when they give you M and B. That's easy. That's the easiest one. The second skill is what we were just looking at. You have to write it when you're just given a graph. That's a little bit more difficult. And the third skill is when they give you a table. That's the most difficult of the three skills. So everybody write in your notebook under bell work, write down number 1, everything highlighted in yellow, and then actually write an equation. So our new chapter is about writing equations. Our last chapter was about graphing them mostly, understanding them.
Sure did. It was so.
All right, now go ahead and write the equation. This is the first skill, the easiest skill. If they tell you slope and they tell you the y-intercept, you're just plugging in for M and B. Write your equation, put the slope in the M spot, put the y-intercept in the B spot. Write an equation. Okay, so here's the answer. Y equals negative 3x plus 1 half. You just put in the M in the M spot, the B in the B spot. Plug in M, plug in B. Easy. Number 2, our second skill. Write an equation given a graph. We were just talking about that with the cell phone data. So now pretend you only have this to go off of. How would you write an equation from it? Let me write the ordered pairs down because it's hard to see. So this is 0, negative 3. You guys go ahead and draw this graph in your notebook. And write the directions, write an equation. Leah, are you doing this? So look at it. You're going to start with y equals mx plus b. You're going to count, rise over run. The rise over run gives you your m value. And then you identify the y-intercept b, plug it in, and you have your equation. count my slope here. It goes up 1, 2, 3, 4, 5, 6. It goes right 1, 2, 3, 4. We'll talk about that for a minute. The M value is up 6, right 4. Big ideas math would call this wrong. This is marked wrong in the math program. What do we have to do with it to get it right? No, they don't want a mixed number. You have to reduce your fractions to get it right in big ideas math. I have a lot of students doing a lot of really great work, but it's coming out totally wrong because their fraction isn't reduced even though it's right. So the top divides by 2 and the bottom divides by 2. That means this slope is up 3 over 2. And you can count and see if that follows the line. Does it go up 3 over 2? Yes, it does. It's just not the point given, but that is a point. Okay? So 6 over 4 as a slope is the same as 3 over 2. All right. So this equation is y equals 3 over 2x. And what's the b value? Negative 3. So I'm going to change my plus sign to a minus sign. The y-intercept is negative 3. That number down there, that goes in the b spot. All right, now you do that for number 3. I'll write the ordered pairs down. It's 0, 2, and 4, negative 1. Try to get the slope right and try to get the b value right. So you start with y equals mx plus b and then count your slope. You kind of slow down. Let's look. This one's kind of weird because the line's going downhill. So I'm going to need a negative number. So I'm going to count down 1, 2, 3. I counted down 3. And 1, 2, 3, 4. Right 4. Start from one point, count to the other point. So on this one, the m value is down 3, right 4. The b value is on the y-intercept. It's a 2. Our equation is negative 3 over 4x plus 2. Writing the equation given a graph. That's the medium scale. All right, last one. There's 2 of these. This is the most difficult one for today. Right, y equals mx plus b, just given a table. So you start writing the formula down, mx plus b, the form, slope intercept form, and then you have to figure out slope. You can do slope formula, or you can just observe how the table changes. So I'm going to give you guys some time in your notebook. You copy this table down. And then you show work on trying to find slope. You guys know slope pretty well. You try to find slope. You got slope? No, what I have written in green here is actually pretty important. Remember that slope is change in y over change in x. So how are the y's changing? When I look at how 5 goes to be -1, I observe it, it's plus 6. No, it's not. How far does 5 go to go down? -6. That's going down 6. -1 to -7 is down 6. -7 to -13 is down 6. So the y value is changing by -6. It goes down 6 every time. Now let's see what the change in x is. -3 to 0 is up 3. 0 to 3 is up 3. 3 to 6 is up 3. So the change in x is up 3. So when I look at the table and observe how y's and x's are changing, y's are going down 6, while x's are going up 3. Notice I put the y's on top and the x's down below. Big ideas math is going to count this wrong. We have to reduce it. 6 divided by 3 is 2, so our slope is -2. All right, so our equation is -2x minus 1. Where did I get the -1 from? Right here is a really special point in the table. The point with x equals 0 is your b value. So you should write this down too. Where x equals 0 shows the b value. There's other more complicated ways to calculate b, and we'll probably get into that. But if they're gonna just show you, you should use that. Now 5 looks like a trick. Something very tricky about 5. I'll give you a moment. I put it on here, that means it must be in your assignment. I'll give you a moment. Copy it down. I want you to think about what's happening in number 5. Something wrong with it. You know? What's wrong with it? Why is it all the same? So what are we looking at? What's it look like? Maybe plot those points and see what it looks like. Decide what you think the equation is. I have to plot it. When I go over it, I'm going to plot those points. Yes. She's got it. She visualized it. What's it mean when the y's aren't changing? What is that? You know the equation? So is it this? like that. So that's 0. No, this one's undefined. Okay, so following my same thoughts before, if I look and see, this is changing by 0. So my slope, my change in y is 0. No changes. And then my change in x, up 4, up 4, up 4, is changing by 4. Now 0 divided by 4 is 0. So our slope is definitely 0. So I have y equals 0x, no change. And then my special point is here, where x is 0, shows the b value. So that's minus 5.8. 0x is just 0. So this equation is y equals negative 5.8. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. -6. So we're looking at these points. 0, negative 5.8 is here. 4, negative 5.8 is here. 8, negative 5.8, and 12, negative. This 0 slope is a horizontal line. This is no slope. There's no rise, there's no fall. Doesn't go up or down. That's a no slope line. If the x's were 0, that means there's no run. That's undefined. Okay? All right, that's all I have for you guys. You guys are going to turn to page. Who wrote it down? What page is it? I got it here. I don't know why I'm asking. Just being lazy. You're doing page 307, 1 through 13. You got 9 minutes to work on it. Please, if you're making noise, let it be on task. Helping each other, working through the problem. Not just joshing around. 1 through 13 on page 307. Writing the equation.
No.